Hey guys, my name is Oladipupo Johnson. I'm from Nigeria and I'm participating in Challenge 2014. I'm going to be answering question 8 under the Math 1000 in the OMED Challenge 2014 Resources Folder. In the question, they mentioned that the volume of a sphere is 4/3 pi r cubed. Yes. Now, they also mentioned that the rate of change of volume of the balloon, the spherical balloon, was 25 cubic inches per second. From here on out, I'll write this as 25 in cubed s minus 1. Okay, we want to calculate the rate of change of the radius. When the radius is 18 inches. Okay, so now we have our information: 4/3 pi r cubed, 25 cubic inches per second, and then 18 inches. Now, differentiation has to do with the rate of change of one variable in respect or with respect to another. For example, if you have the function x, and say f of x is equals to, let's say, 4x squared plus 2x. If you were to differentiate this to make it f prime, you would get 2 times 4 x raised to the power 2 minus 1 plus 2 times 1 times x raised to the power 1 minus 1, which is equals to 2 times 4 x raised to the power 1 plus 2 times x raised to the power 0, which ultimately equals to 8x plus 2. F of x is equals to k, where k is a constant, x raised to the power n. The formula for differentiating this will be equals to n times k times x raised to the power n minus 1. So if you apply this here, you would see that it equals this. In differentiation, there's something called the chain rule. Now in the chain rule, what you do is you use the information you already have as regards to two separately changing rates, or two rates that have already been given to you, and then you equate them in such a way that you get a totally new rate that has not been provided in the question given. Take function y, where y is equals to 4x squared plus 2x. When you differentiate, you write it as dy dx, which will be equals to 8x plus 2, as previously explained. Let's say we wanted to calculate the rate at which y changes in respect to time, which would be dy over dt. The y dt is actually oriented from the Greek letter delta for change in y over change in t. So that makes this a rate, because you're changing in respect to time, t. Now, if you want to calculate the y dt, it's going to be equals to dy dx times dx over dt. If you look at this, eventually, arithmetically, this should cancel out. So you're basically just manipulating it before you cancel out to get your answer to be equals to dy dt. Okay? Now, let's apply that to our question. We have volume V to be equals to 4/3 pi r cubed. Now, pi is a constant, as we all know. 4 is a constant, and 3 is a constant. The only variables here are the volume and the radius. So, if we differentiate V with respect to R, we have dV dr will be equals to 3 times 4 pi over 3 r squared, or 3 minus 1, as I previously explained. This should cancel out to give you 4 pi r squared. So this is the rate at which the volume is changing with respect to the radius. Now we have that. Write this as equation 1. Now, if we now calculate, we already know what dV dt is, which equals to 25 cubic inches per second, as previously stated here. Yeah. Now, if we apply this rule into this, dV dt divided by dV dr, which is divide the rate at which the volume is changing with respect to time by the rate at which the volume is changing with respect to the radius. This will eventually equate to dV dt times dr over dV. And then from what we know, this should cancel out. Yes. So if we substitute values into this, we will get dr dt is equals to dV dt, which is 25 cubic inches per second, times 1 over 4 pi r square, which is the inverse of this, as shown here. Okay, this will equate this to 25 over 4 pi r square. Now, looking at this, we're meant to calculate it when the radius is 18 inches. So when r is equals to 18. If you substitute the values of r is equals to 18 into this, the r dt will be equals to 25 over 4 pi 18 square, which is give us 6.14 times 10 raised to the power minus 3 inches per second. 6.14 times 10 raised to the power minus 3 inches per second. And that is your answer. Thank you so much for your time. My name is Oladipupo Johnson once more, and I'm looking forward to going to challenge. Thank you.